In this video, we are going to extend the idea from the last video of homogeneous linear ODEs with constant coefficients. In the last video, we completely focused on second order homogeneous linear ODEs with constant coefficients, but this one we're going to extend it to higher order, so above 2. So that means it works out the exact same way. I'm going to give a high order DE. We're going to plug in, it's the same idea of plugging in this e to the mx is probably our solution based on what we have observed. Once we plug that in and our double and as far as we need, and we plug it all in, we get down to what is called our characteristic equation, just like last section or last video, same set of sections. Now we're just going to deal with a higher order characteristic equation. For me, in my class, this isn't you solving a high order polynomial isn't my concern. So we will use some kind of Desmos or Grapher or Solver or something to help with our polynomials. In class, I will just, you will need to make sure to have a calculator. I'll bring a couple of my graphing ones if you want to get used to that and the higher order polynomials. So with that, let's talk about what changes. Case 1. So it's the same type of cases. They're all distinct real roots, however many roots I may have. I may have more, I may have 10, depends on the polynomial that we're dealing with. If that's the case, then it's that same scenario where we just do e to each root x. If it's repeated, it's the same idea. I start with e to that root x, then I put an x in front of it for the second one. And you could do, if you wanted to, you could do reduction of order to see these. I go up by another x, and I just keep multiplying by x going up, and then the last root will have x to the n minus 1. It's not the same. For me, when I first looked at this, I was like, oh, that should be x to the n, but it's not because x to the first starts here. So if it's 1 off, then we're not going to get all the way to n. We'd get 1 less. That's case 2. Case 3 is the solutions are complex pairs, and we get the same thing. You take y1, you do that, y2, you get that. That's based on that complex pair. Here, we're going to have a different alpha, different beta that we'd use, and a different alpha, different beta, and I'd get those. And we just keep applying those until we use all our roots. Let's take a look at a few examples of these. So I could work with this, y equals m to the x, and then I could go to y prime and do m e to the mx, and then y double prime and get m squared e to the mx, and then we need a third derivative, which is m cubed e to the mx. Just chain rules. I could plug all that in. Using all that, we would have the characteristic equation, m to the third minus m squared minus 4m plus 4 equals 0. Now we're dealing with a cubic. I'm going to show you a method that works sometimes with cubics. I could group the first two together. I'm not changing much. And then I got to change this sign, but notice the way it distributes. This goes here, that goes here. I got to change the sign in the middle. So I have that. And now I'm going to factor out the common in each group. So I'm there. Factor out a 4 on this one. And then I want you to notice here, I have what looks like a term. It's just separated by a minus sign. Not officially a term, but it looks like it. Two quote-unquote terms. And notice they both have m minus 1. So what I'm going to do is factor out m minus 1. Now what's left is I would need to multiply by m squared, and I need to multiply by 4. So now I have that factored, and then maybe you see it, maybe you don't, but right there is the difference of squares. So it factors to m plus 2, m minus 2. Hopefully you remember that from pre-calc 1. There we go. It's completely factored. Now I actually have solutions. I got 1, -2, and +2. So the solutions for my equation, since I got real numbers, is y1 equals e to the 1x, y2 equals e to the -2x, and y3 equals e to the +2x. If you want to put the negative last or first, you can. It doesn't matter. So the general solution for this DE is y equals c1 ex plus c2 e to the -2x plus c3 e to the 2x. So, we did make a jump that these would be linear, linearly independent, and they are. You can tell. There's no constant I can multiply to get to the one to the other. So there's my general solution. This is really nice if that works out like that. If this is called factor by grouping. Factor by grouping. Sometimes it works, sometimes it doesn't. So you could try it. If it doesn't work, then you move on. And we're going to use a grapher to help us. So there's our solution to that one. Let's check out example 6. So the same stuff. I'm just going to write down the characteristic equation. Some teachers, professors will let you just write it down. I think mine let me write it down. I know some other professors, typically more picky ones, don't want you to do it. They want you to actually write it out. What I mean by is take this, e to the mx, find y prime, find y double prime, find y triple prime times, and then the fourth prime. If you take all those after you calculate it from the original one and you plug it in, you would factor it out and you would be left with this characteristic equation. M to the fourth minus 6m to the third plus 9m squared plus 6m minus 10 equals 0. The only thing that I would require of you, jumping this step, would be to say that this is my characteristic equation. Now notice that one isn't going to work factor by grouping. Maybe I could put two of them together, maybe, but I'm not going to end up with the same thing inside my parentheses after I factor it out. So with this, I am going to use Desmos. You are allowed to use your graphing calculator. So I'm going to type all this in. I got x to the fourth power. Let me go to the actual app. Actually, here we go. X to the fourth minus 6, x to the third. Oh, wrong thing. X to the third. Get out of the exponent. Plus 9x squared. Plus 6x minus 10. So there's my graph, and all I'm going to do is I'm going to try to click on those points. Maybe I can pick up one of those. Hopefully they're nice, pretty points. All right, we got point 14 and that. So I'm guessing point 14 probably works. I'm going to check to make sure that's a 0. Point 14, and I'm going to do this maybe a way you remember, maybe you don't. I'm going to run it through synthetic. If it's a 0, then I should get 0 in my remainder. So I write out, this is called synthetic division. Close that. I get 1, and I leave the coefficient. I write down the coefficients and I leave the variables off. -6, 9, 6, -10. And to check synthetic division, it works going down here. Then I multiply, so I get 0.4. Then I add, I got -0.56. I'm going to need a calculator for this. I'm trying to find one here, my stuff. So I got 0.4 now, times that, -5.6. I'm trying to confirm that it is a 0 and they didn't round. I got -2.24, and I add 9 to that. I got 6.76. Then I times that by 0.4, and I got 2.704, and I add 6 to that. I got 8.704. Then I'm going to multiply that by 0.4. I think it was supposed to be a 14. No, I'm second guessing. And of course it didn't remember it. All right, I'm going to type this thing in again just to make sure we're good. So I have x to the fourth. Then I have -6 x cubed. Going back to the end of my equation there. Okay, 9m squared. I don't know why it keeps not picking up my 9x squared. 6m. And then I think it's plus 10 or minus 10. Minus 10. I think I plugged it in wrong the last time. Let me double check that that's right. I got x to the fourth minus 6x to the third plus 9x squared plus 6x minus 10. Yeah, there we go. So notice now these zeros work out much better. So I'm going to use those two zeros to find the other two zeros. So forgive me. I knew it didn't feel right. So these won't be here. The zeros that we came up with, so what we did, just refresh here, I typed this into Desmos and I found where it was 0. The zeros that I got were m equals 1 and m equals -1. So what I'm going to do now is I'm going to work backwards here. I'll just show you how this works. I'm going to put a 1 here into synthetic. And after I do this, it's going to take out that factor of my equation. I'll show you what I mean. So this brings 1 down. I multiply, I get 1. I add, I get -5. Then I multiply this by that. It's always back up to that 1. I got -5, which gets me a 4. I multiply 1 times 4, I get 4, which is 10. 1 times 10 is 10. And I get a 0, like I expected. If it's a 0 of my polynomial, then I get a 0 remainder. Now what that does is, this says after I do that kind of division, I get left with 1m and it's 1 less. So it was to the 4th, now it's to the 3rd. And I have that. Where'd it go? Squared m plus 10. I just count down. Now I'm going to run that same thing, but with a -1. And this is going to tell me what's left after I take out the -1. So the 1 comes down, I multiply, I got -1. I add, I got -6. I multiply, I got 6. I got 10. I multiply, I get -10. I knew it was going to be fine. I get a 0. So I do have this. M1 equals 1. M2 equals -1. And now I need M3 and M4. I know there are going to be 4 because the fundamental theorem of algebra tells me there will be 4 because it's to the 4th power. So now the remaining function, the reason I went through all that synthetic stuff is because now I just have to solve this, which came from my remaining coefficients. This, does this factor? It does not. So I'm going to use the quadratic formula, write it out every time I use it so I don't forget it. If you don't know it, it's time. You got to get it figured out. All right, so I do the inside over here, b squared minus 4ac. Okay, b is -6 squared. Make sure you put that in parentheses. 4 times 1 times 10. So I get 36 minus 40, which gets me a -4. So I'm plugging all this in now. Opposite of b gets me a 6. This is a b. Plus or minus the square root of -4 all over 2 times 1. This is 6 plus or minus 2i over 2, which is 3 plus or minus I, and that's a 1. So my other solutions, I know it's going to be e to the 3x cosine of x, 1x, it's beta x, and then the other one is e to the 3x sine 1x. So there are all my solutions there. All right, I have a couple things. Yep, so we have these. So those are our solutions. Let's write these out. So y1 equals e to the 1x. y2 equals e to the -1x. y3 equals e to the 3x cosine 1x. And then y4 is e to the 3x sine x, which means my general solution is c1 e to the x plus c2 e to the -x plus c3 e to the 3x cosine x, and then c4 times, I forgot the e to the 3x sine x. So there is my solution. So the whole point, what I wanted to point out is you can use a grapher to figure this out. Terrible color choice. Figure this thing out. Once I have that, then I can use synthetic to get it down to something I can actually solve. M to the 4th, it would be a little more difficult to solve. So what I did is I just plugged in this thing, and then I looked to see when that function crossed the x-axis. Now, I'm only going to use whole numbers there if it works out. Otherwise, I'm going to need to find another way. This would be a great time if you're struggling to solve a certain polynomial to go ahead and look it up and figure out how to solve that type of polynomial. All right, so I have a couple more equations like this to solve, just to get us some reps under our belt. Oh, this is the last one, actually. So this may end up being quite a bit. I am going to not work through, remember, we have that this is probably some solution, which tells me that we get all these derivatives, right? And we're going to work all the way down to y to the fifth derivative is m to the fifth e to the mx. And I can plug all that in, work it out, and end up here at the same place that I can just write down. Characteristic equation. So this is m to the fifth plus 6m to the fourth plus 13m to the third plus 14m squared plus 12m plus 8 equals 0. So notice probably aren't going to do any kind of factoring to get to this. So we're actually going to use Desmos again. So let me pull up Desmos the way I had it so I can just type it. All right, so plugging this in, okay, I got x to the fifth plus 6x to the fourth. Oops. Plus 13x to the, doesn't get half the stuff I push on here. 13x to the third plus 14x to the second plus 12x. And then the last thing is plus 8. So I can pick this up. Looks like there is a 0 at -2. So I know, and it doesn't look like there are any other real zeros, so I can expect to have imaginary. I know that M1 was, I already forgot, was it a 2? I think it was -2. Then I need M2, M3, M4, and M5. I know that this isn't a repeated root. The reason I know is the graph looks something like this. Really bad there, but something like this. Right, and cross through one time. If it crosses through, it's definitely not going to be repeated. A repeated is it bounces, if you remember from pre-calc. If not, that's okay. So I know that is a 0, so I'm going to run that through synthetic so I can get the remaining part of my polynomial. So 6, 13, 14, 12, and 8. The 1 comes down. Then I multiply, I got -2, I got 4. Then I multiply, I got -8. Then I got 5. Then I multiply, and then I add, I got 4. Then I got -8, which is 4. And then I got -8, which is 0. If it didn't come out as 0, you did something wrong because you know that's a 0. So now I just count down. I got 1, and I start at 4 now. 4m to the third plus 5m to the second plus 4m plus 4 equals 0. So now, hopefully we can come up with some other way. This is what I would like to do. We could graph it, but it's not going to actually work out for us too well because I know they're going to be imaginary. All right, so we could, let's work from there. I'm going to use a solver. So I'm going to go online. I'm going to use my computer that's in front of me, not my iPad. And let me log into my computer. And I'm just going to look up Polynomial Solver. And hopefully I get something that will solve it the way it is. And give me imaginary, that's the thing. So I really would like imaginary numbers. Some of you guys may have this actually programmed into your TI-84 or 3. You can actually program this thing. Let's say Polynomial Solver. So I'm plugging that in. I just typed it in. There's a calculator here, right? And it gave me a bunch of things to put in there. So I'm going to try it. So I got m to the fourth. I'm going to stick with x. X to the fourth. Plus 4x to the third. Plus 5m to the second. Plus 4m plus 4 equals 0. So I want to see if it'll solve it. All right, so I plugged it in the solver. And we do, looks like, okay, solving with the quadratic formula. Oh, I put m's and x's. Give me a sec. It's like freaking out on me. There we go. All right, so here are our imaginary. I get I and negative I, and then also I get another -2. So -2 in this case was a repeated root, even though our graph didn't really look like it. I guess I stand corrected. That we do get -2 again. So I have another -2. So we're good there. And then the other ones using a solver online. If I wouldn't do this to you on a quiz. On a quiz, I'm going to have stuff that works out or something that I can grab imaginary using the quadratic or something. I'm not going to do any of these the high order ones. I'll give you something that will work out for you. All right, so solver online gave I and -I. Right, and we actually get a repeated root there again, which is interesting. So I got I and -I. How I'm finding these repeated roots is the solver is only giving me 3 answers. It gives me that one and then the other 2, and this isn't going to repeat. This isn't going to repeat, so the repeating has to be a -2. So the -2 does repeat. Now what that gives me, if I'm writing out these answers, I got y1 equals e to the -2x. Then I have y2 equals, let me scoot these over. Y is x e to the -2x. And then since it repeats 3 times, I got x squared e to the -2x. I also have 4 and 5. I'm going to go down because I need more room. Right? This is going to be e to the 0x times cosine 1x. Or this is just cosine x. Y to the 5th is going to be the same scenario, but I have a -x, so this is cosine of -x. Cosine of -x, if we're thinking trig, and here's my x. Cosine is symmetric, so it does something like this, right? Symmetric. So -x, I'm just going to think about what would happen. Well, it would get me the exact same thing. So I actually have that's the same thing. It's repeated. So y to the 4th is going to be cosine x, but y to the 5th, oh, it shouldn't be a cosine. There was my mistake. I was like, wait, why is it the same? Okay, this is actually a sine. Let's go back completely. M to the 5th was 0 minus I, 1i. So we have e to the 0x, and then sine -1x. That just leaves me with sine of -x. The way sine of -x is we get negative, if you don't remember this identity, but we get negative sine x. You could have totally left it sine -x. That's perfectly fine. My trig is pretty fresh, so I do remember that. So now I have that, cosine x, and negative sine x. Those were all coming from the zeros of our characteristic equation here. We get the first 3 across the top here from the repeated roots here, all the -2s, and then we get the 2 below, this thing and that thing here came from our i's. So I can write out a general solution. GS is y equals e to the -2x. I forgot my c. C1 e to the -2x plus C2 x e to the -2x plus C3 x squared e to the -2x plus C4 cosine x plus C5, and I'm going to go ahead and throw that a minus out there, sine of x. There we go. So the hardest part, I think, is the whole recalc of finding zeros of a polynomial. Please use graphers and solvers. On a quiz, I will probably I'll probably leave it lower order, 3 or 4. If it's a 4, hopefully I can make it work out where it graphs nicely or something like that. I won't make it nasty on a quiz. Your homework, on the other hand, may be different. If you watch Sasha's video, Sasha actually uses old pre-calc techniques to solve these things. There is something called possible zeros theorem. It depends on what book it is, what it's called. But there's a way to find all the possible zeros in her videos. If you guys go check out her YouTube channel, she actually goes through that. I'm not going to hold you guys to that. I'm going to stick to the DE stuff, to the calculus, and let the algebra stay down just a bit. So good luck. Make sure you're getting through your homework, because you need to work on scenarios that are sticky like this.